Have you ever looked at a picture that seemed to move even when it was completely still? Or how about when two lines that look completely different in lengths are the same lengths? Optical illusions catch our attention because they trick us into seeing something that isn't actually true. Today, I will be explaining how optical illusions work and why they trick the brain into seeing something that's not there. I chose this topic because optical illusions combine science and psychology, both helping people understand how perception works. First, I will demonstrate how the eyes and brain process visual information. Then, I will show different examples of optical illusions. And lastly, I will explain why these illusions work in the first place. To begin, I will demonstrate the Mueller-Eiler illusion. Take a look at these three lines and decide which one appears longer. Many people believe one line is longer than the other, but in reality, all lines are exactly the same length. This illusion works because of the brain being able to automatically use its surrounding visual cues to interpret depth and distance. The direction of the arrow shapes makes one line appear farther away and the other one closer, which causes the brain to adjust how large each line may seem. Even though our eyes receive the same visual information, the brain interprets it differently, showing how perception can be influenced by context rather than reality. Now that we understand how the brain interprets size distance, let's look at how it can also be tricked by size and lighting. The next example is called the checker shadow illusion. When you look at this image, square A appears much darker than square B. However, both squares are actually the exact same shade of gray. This illusion happens because of color constancy. As Neurolaunch said, and I quote, color constancy refers to the tendency of perceived object colors to remain relatively constant under varying illuminating conditions. The brain then assumes that an object in a shadow must be lighter to compensate for reduced lighting. Even though the color itself has not changed, therefore the brain interprets the two squares as different shades, even though they are physically identical. It demonstrates how perception is influenced by context rather than reality. After seeing how the brain processes images, let's continue the demonstration by exploring why optical illusions are able to trick the brain. This image is an example of a motion illusion. Even though the picture is completely still, many people still see movement in the image. Do you? This tends to happen because the brain constantly predicts motion based on contrasts in color, light, and shape, while small voluntary eye movements send changing signals to the brain. Instead of processing every detail perfectly, the brain relies on mental shortcuts to quickly interpret visual information. These shortcuts are actually helpful for understanding the world efficiently, but optical illusions reveal that they can also lead to incorrect perceptions. This demonstration that vision is not just about what the eyes see, but about how the brain interprets and predicts information. As McGovern Institute has stated, your senses send information to your brain about the world around you. Your brain plays the role of detective, piecing together each bit of information to figure out what is happening in the world. As we come to the end of this demonstration, we can see that optical illusions reveal more than just interesting pictures. I first prepared visual examples to demonstrate optical illusions, then showed how the brain processes visual information, and lastly demonstrated why optical illusions trick our brain in the first place. Skyscape has stated, our visual system is a highly complex network designed to interpret and make sense of the world around us. This shows that what we see is not always the truth, but instead the brain's interpretation and visual information. Optical illusions remind us that perception is very powerful, but it is not always accurate.